I'm Alan Doherty. I'm a professor of physiology and medicine. I also direct the Sahara Cardiovascular Research Institute and chair of the Department of Physiology. So I've been at the University of Kentucky now for 24 years, and during that time, most of my research is focused on diseases of the aorta. And of late, our research program is very much focused on the thoracic aorta, which is just where the heart and aorta are linked. And there's a lot of diseases that are common in both genetic and non-genetic basis that are really untreatable at this point for anything other than surgery. The main thrust of our research program is trying to find mechanisms by which we can attenuate the swelling of the aorta in these different regions, hopefully stop them from rupturing, which is the catastrophic endpoint of these diseases. It can be two manifestations that we think about. One is TAAD, so that is thoracic aortic aneurysm. And that's where, for reasons that we are not clear, there's just a progressive expansion of the aorta. And the problem with that, of course, is at some point it expands to the level where it has insufficient strength to maintain its integrity, and unfortunately ruptures. So the dissection means that the wall of the vessel is split in half, and basically blood is then going through that blood vessel. And depending on where that happens, it can be very difficult to correct in any surgical way. So at the moment, any patients with these diseases, if they do get diagnosed, the only thing that will happen is there'll be sort of watchful waiting. What we're hoping with this research is that that won't be the only option for these patients. We hope that we can find pathways that if someone gets diagnosed with this disease, we'd be able to give a drug therapy that would stop the attenuation so that they wouldn't have to go to a surgical intervention. We've got excellent facilities at the University of Kentucky to perform this work, in which we tend to generate, either by genetic manipulation or by chemical manipulation, the development of this disease in mice that bears striking similarities to the human disease. So this is a R35 grant, which this is a mechanism that the NIH put in place to really focus on the individual rather than the specifics of a project. So the 7 years of support is not very structured, so it allows a lot of flexibility for the recipients of these awards to really be very inventive and move in different directions for their research programs. At the University of Kentucky now, the Cardiovascular Center has 3 people with these awards, so I think that's actually quite noteworthy that we have such a aggregation of these very significant awards within one area of research. It actually shows the strength of cardiovascular research across this campus, and which is of course very consistent with the designation of cardiovascular research as being a research priority area by the Office of the Vice President.